This is a tutorial on calculating speed, velocity, and acceleration. Here are two equations you will see for this chapter. Also, just so you know, you will never be required to memorize an equation for my class. All equations will be provided for you on any quiz or test just as they appear on a worksheet or something like that. These two equations look very similar because remember speed and velocity are pretty much the same thing. They tell us how fast something is going, except for velocity always has a direction. And they're both calculated by doing distance over time. The markings in blue are showing you the possible units for these variables. D, which is distance, can be either meters, kilometers, or sometimes you may see centimeters. And T, which is time, your possible units there can be seconds, hours, or minutes. Our second equation is for acceleration, which is symbolized by a lowercase a. You see a symbol that looks like a triangle. This is called a delta. It's a Greek symbol, which means change in. And so you're calculating the change in velocity over time. To do change in velocity, you take your final velocity and subtract your initial velocity from it and divide it by time. For acceleration, the possible units you will see would be meters per second squared or kilometers per hour squared. Here are the list of steps that you should always be sure to follow. First and foremost, you need to read the problem. You will then identify and write down all the numbers that you're given. Next, you decide which equation you're going to use. Sometimes you may need to manipulate it a little bit differently. I'll show you in one of our examples what I mean by this. You will then insert your numbers and solve. You want to show your work. You may use a calculator. Finally, you will put a box around your answer so that if I'm grading it, I know that that is your final answer. All answers must have the correct number of significant digits and a unit. Here is the first example. It says the cheetah, the fastest land animals, can run 274 meters in 8.65 seconds at its top speed. What's the cheetah's speed? We're only given two numbers. There's 274 meters and the 8.65 seconds. The 274 is a distance, so I write D equals 274 meters. My time is 8.65 seconds. I figure that out just by looking at the units. I'm trying to solve for speed. That is my unknown. The only equation I have for speed is equal to distance over time. So, you take your distance over your time, you do 2.74 meters over 8.65 seconds. You put that in the calculator. 2.74 divided by 8.65. I put that in the calculator. I get 0.31676 and some other numbers. I now need to decide how many significant digits my answer should have. 274, that's 3 significant digits. 8.65 is 3 significant digits, so my answer must have 3 significant digits. Here are 3 significant digits, so my final answer I write as 0.317. I rounded the 6 because the number next to it was greater than 5. My unit is meters per second. Meters for distance, seconds for time. Put a box around my answer, and now I am done. Now on to example number 2, which reads, Suppose a polar bear is running on land instead of swimming. If the polar bear runs at a speed of about 8.3 kilometers per hour, how far will it travel in 10 hours? Again, we're only given two numbers, 8.3 kilometers per hour and 10 hours. 8.3 would be the speed. Our time is obviously 10 hours. It's asking you for the distance, so that is our unknown because it says how far. The equation I start out using is distance over time. This is one of those you will have to manipulate, okay? We already have speed, we already have time, but distance is my unknown, so I need to get distance by itself. To do that, I need to get rid of t on this side. So I multiply both sides by t. Doing that cancels time on my right side. On the left side, I'm left with time times speed is equal to distance. Now, just like before, I can insert my numbers. My time is 10. My speed is 8.3. You multiply 10 by 8.3 and you get 83 for your distance. You now need to check for significant digits. Go back and look at the numbers that you're given. 8.3 has 2. 10.0 is 3 significant digits. Because 8.3 only has 2, my final answer can only have 2. Luckily here, 83 is 2 significant digits. The only thing I need to add to my answer is a unit, which here is kilometers. Put a box around it, and you are done. Example number 3, our last example. It says, a flower pot falls off a second-story windowsill. The flower pot starts from rest and hits the sidewalk 1.5 seconds later with a velocity of 14.7 meters per second. Find the acceleration of the flower pot. So it's very clear what's our unknown. That would be acceleration. Let's go through and identify our numbers. First number we get to, it says 1.5 seconds. Seconds is clearly a time. Then it says a velocity of 14.7 meters per second. Remember the equation for velocity says VF minus VI divided by time. Therefore, that means we should have been given 2 velocities. You can't have more than one unknown in a problem. So we need to figure out where is the other velocity. If you go back to the second sentence, it said the flower pot starts from rest. If something is starting from rest, that means its velocity is 0. That's my initial velocity of 0. Starting from rest is 0. So this 14.7 must be my final velocity. Here is an equation I do not have to manipulate. Acceleration is my unknown, and this equation solves for acceleration. So I just insert my numbers. I have 14.7 minus 0 divided by 1.5. Obviously, 14.7 minus 0 is just 14.7. So in your calculator, you would put 14.7 divided by 1.5. When you do that, you get 9.8. Okay. Again, as we've done for all the other examples, check for significant digits. 1.5, 2 significant digits. 14.7, 3. We do not count 0 when we're considering significant digits because 0 was not given in the problem. It was just understood. So we go with the smaller number of significant digits, which is 2. Again, luckily, our answer from our calculator only gave us 2. All I have to add is a unit. I had meters per second and seconds. So my unit for acceleration here is meters per second squared. Put a box around my answer and you are done. You are done with this tutorial. Hopefully it was not too painful for you. Remember, your homework grade for tomorrow relies on you being able to answer some simple questions about this tutorial. So make sure that you have watched it and can answer simple questions like, what's a possible unit for time? That's an example of a question I will give you. It will be worth a homework grade, what we do in the beginning of class, okay? Also, we're going to work through some more examples. These examples were very simple. It may get a little bit more difficult for some of you, but we will work through those examples tomorrow in class. So things you need to make sure that you have with you are your calculator, some lined paper, and a pencil. You can do it in pen, but I know some people like to do math in pencil, so if you're one of those people, make sure you bring a pencil to class. I hope you all have a good evening.